Thank you for joining I Am Possible, which is India's first future tech meets sustainability podcast. And today I'm delighted and honored to have with me Mr. Walter Crismareanu, who is an IT expert with 40 years of experience and is the founder and CEO of Tipalo, who's working on the theory digital brain with artificial nervous systems. So, Walter, really appreciate you taking time and being part of the podcast. Why don't we start with a brief introduction on who you are?
Yes, so my name is Walter Crismareanu. I am a CEO and founder of Tipalo. Tipalo stands for time-based pattern logic. I have started writing my theory mid-90s. 3 years ago, there is a company called Xilinx, right, who was bought for 35 billion by AMD. And then they are an FPGA specialist. FPGA stands for programmable chip, And then, as I mentioned, 3 years ago, Xilinx brought a new chip on the market. This chip was a combination between programmable logic on the one side with very high capacity, and on the other hand, it contained a special memory called HBM2. So this is the fastest and the highest, with the highest bandwidth available. And then they put them together, one on top of the other. And so we have it. And then I bought a board from Xilinx. And then I started to work. So in order to implement the theory in the technology, what are we going to do? What are the levels here? So there are different levels of software in this implied. In our case, we had to start from scratch. Why? Because we don't use conventional computers. Therefore, we don't have an operating system, and therefore we don't have the applications. So we had to start from scratch. This means we have different levels. The first level is the hardware. So instead of processors, we have dedicated processing engines, which is not comparable with normal processors, because normal processors, they work in serial mode, one after the other, one after the other. We work in parallel. This works in parallel. I will come back to this. And then the second one is the operating system. Well, the operating system, in our case, is actually a framework. Why? Because the framework consists of individual units, and each unit is actually a neural net. A special neural net called spiking neural nets, which uses only the neurons, the active neurons. This also implies that the neurons are not active at the same time. And then at the end, we have the software, and our software is actually the synapses between the neurons. We see neurons as logical units, what we are doing. And then the next one is a little more complicated because we combine hardware with software. What does this even mean? Well, this means that for us, the software is the synapses, but the synapses can be added, new synapses can be added to the existing ones. And this means that because our synapses are virtual, means they don't exist, but they are only activated when needed. This implies that hardware and software are merged. So the software can create hardware, in this case, the virtual synapses. And on the other hand, the software only processes synapses which are present. I know it's a paradigm, but once we get to understand this, it's the only way to get to a digital brain. And the digital brain is actually what? Is our FPGA with the memory inside on the one hand, and on the other hand, the software, which the software is actually as I mentioned before, the synapses. Now, having more than one neural net, for example, a couple of thousands, this implies that each neural net will have to have its own processor, its own hardware, right, which processes the synapses. and then connecting this to the outside world, like sensors, uh, cameras and gyroscopes and whatever. And on the outgoing side, we have servo modules which simulate the legs of a biological being, right? And then this combined all together, you see, we have finally, after a long way, the digital brain with the artificial nervous system consisting of neural nets connected to a certain body hardware with sensors, sensors, actors, and not to forget internal organs. Why? Because internal organs are also needed. Why is this? For example, let's take an animal or humans, whatever biological being we take. It's very simple. It acts alone. There is no one from outside, right? We are not a puppet. We have our own free will. Oh, okay. So what triggers our own free will? Our necessities, our bare necessities, our physical and mental necessities. And in this case, the bare necessities are, for example, our stomach. Or for a robot, this will imply his rechargeable battery. It means, are you hungry? Go and find some food. And this is the reason why we need internal organs.
Human brain is so complex. The way it fires and wires, or 70 billion odd neurons, 100 trillion synapses, what they do gives rise to our five senses. And five senses, not just the five senses. I mean, now all of these, to model it onto a computer, the artificial intelligence started in 1960s, and the compute power was not there. But now everything is falling together, and we are taking these jigsaw puzzles of what we call intelligence and understanding it and kind of representing it onto a computer. Now, I'm sure, yes, this is a task which is only those really brave engineers are spending time with, because I guess building a general purpose machine is the larger community looks at the ones who are working towards a general purpose machine. They either ridicule them or say that, oh, this is a complete waste of time. And there's only those really passionate few who are vested in doing the impossible. And I guess, impossible is the state of mind, and I guess that's the reason I do this podcast. So yes, thank you for explaining it so beautifully. And I'm sure it's not like you mentioned. We humans, it's not just the brains. It's the internal organs plus the environment, how we perceive all of that is responsible possibly for understanding intelligence and maybe emulating that or building it onto a machine. How did you think about this? Let's just go back. Give us the background of this theory. How did you develop this, and what are the ideas and inspiration that you have taken in to build this theory of yours?
So I started with my own imagination. And what does this mean? I imagine myself as being somewhere, doesn't mean where or when, and then I take a look at the reality. And the reality for me is an aquarium with fishes inside, and whatever else. And then I can look wherever I want. I have an imaginary microscope where I can zoom in and see everything. Doesn't matter how small it is, and it doesn't touch me because it's only imaginary. And then I also have a time flow, which I can also like a video recorder, where you can stop and then move forward or backwards, but I cannot do something. I do not change this reality in the aquarium. This if something happens, then I can change something. No, this is forbidden. Just take a look and rewind if you want, and take a look closer and zoom in and zoom out and do whatever you want, but don't change. The next thing is we put something else in the aquarium. This means we have a different landscape. I look at, for instance, at the sun inside, and then zoom in and zoom out. And the immense heat cannot touch me because this is imaginary, right? So this method of research is amazing. It put my my knowledge upside down, what I learned in school, everything, and then I saw that this is something different. Okay, now I try to explain it. How do you explain this? Well, I thought, first of all, let's look, what am I looking at? So what is an object in other words? Then we say, what is an object? Well, an object is a problem to define it. It can be something small and something big and so on and so forth. And then I saw, oh, wait a second, we have a problem with our eyes and with our senses, because we see only in an image with 2 dimensions. We can't see in 3 dimensions. We have 2 eyes, yes, and the eyes can only help us. Both eyes can only help us in this case to see if something is beyond the focus point or not. So there is another point. Okay, so I started to write down my problems, one after the other, one day after another, 1 month, 1 year after the other. And then I try to find some explanations. And then, because I'm so passionate about ancient civilizations, and religion and so on, I thought, where can I find this? Because I couldn't find this. Okay, this is a process which takes a lot of time. This means I began this when being a teenager, and it ended up today, but it's already not ended, because it's an ongoing process, right? So let's go back to being a teenager. So I read a lot of Asian culture, Indian, Chinese, Japanese, and then Indian. I saw that there is not only what we in Europe, in the Western world, called Buddhism. No, this is only a very small part. There is much more. Okay, let's have it. So I begin to study, Mahabharata and Ramayana and Bhagavad Gita and Ayurveda, and I practiced yoga and a lot of things. And then these small pieces came together, and then I saw the solution was in how the brain is working in Ayurveda, because Ayurveda says the mind is part of the body. This means it should be work the same way like any other body part, organ, Okay, so I saw the comparison. So the digestive system is practical, the template for the brain. Wow, I was astonished. Okay, I knew it instinctively that this is the solution, but I couldn't know why. Anyway, and then I thought, how about something else? Why do we think how we think? I started to read David Hume, a treatise on the human nature. This is hard work, Anyway, now I saw that I'm not the only one who is questioning himself and questioning what is the world actually doing, And then after a couple of other years, I read Sun Tzu, The Art of War, and then I saw it in my eyes, because as a developer, I started young. I was 15 years old, when I started my first computer language in 1976 in school, in high school. And then I said, you know what he describes here, his theory is actually a system of signals and people who are interacting with each other, the same like in a game, And then I saw, okay, so the brain is the same like a game, not like any board game complex, but using the theory of Sun Tzu. Okay, now we can make a distinction. First, we have a landscape. So this means we have a space. And then second, we have a time flow. In our own brain, the brain emulates the time flow and emulates the space. You can see this in catatonic people, for example. right? Or who don't move for whatever reasons. Anyway, and then I saw, okay, and then what about the object? What is an object? Okay, what is a participant? How do we talk to each other? Communication. And then it it was it was much better. So I thought, let's take the aquarium and now build our own aquarium in our own mind with the knowledge that we have, continuously adapting and also trying to explain it. Never mind how hard it is. If you can't explain, you don't know it, right? Or you don't know it enough. And so, okay. So I was my biggest critic, Walter, this is not like, okay. So at the end, I made a model and I said, okay, the brain emulates a space, a logical space. Why does it do this? Because it's a representation of what you see outside. But how is this representation evolving? And then I said, okay, let's take the babies and let's take the kids and the teenager and the adults. How are we perceiving the world and how does that change our brain? And I said, okay, now I have it, because I was spending about 8 years in a kindergarten, teaching kids. And then I said, oh, now I know it. Okay, so what did I learn from this? And then I said, okay, now we have our model. So the model was first the space, and then we have the time flow, and then we have the objects communicating with each other. Okay, but there is something else, and this is the most amazing thing. An object is actually it's actually a very well-defined organization. There are 3 levels. First, you have the basic components. Second, you have the grouping together, and then you have at the end you have the network. Let's take a comparison. Chemistry is the best known. Why? In chemistry, you have the basic components, which are the atoms from the periodical system of elements. And then they build molecules, which is the grouping. It doesn't matter if it's small or big molecules. And at the end, you have a network. And then the network consists of many groups. Static groups and dynamic groups. What is this? So static groups, it means that the connection is always there. And then you have the dynamics groups, which trigger the others, which is in charge of command and control, so to speak. Et voila, here I had the complete model in my brain. And then I said, wait a minute, this model is also in nature. If you take chemistry, you have it, as I explained it. If you go down, further down in physics, it's the same. And if you go further up in biology, which is the basic component? The cell. Okay, and what about the brain, which is the basic component? It's a specialized cell, but still a cell called neuron, which is doing the same thing, connecting with each other and so on. The only thing that is more, in addition to this, is actually that a connection can be active or inactive. This depends, and this is the spiking neural net. And this is how I came to build it. Long way.
Spoke about how you are leveraging the information of our ancient culture, and if you dug deep into various religions, including Mahabharata and Bhagavad Gita, I'm sure there are heaps of information over there. And you also mentioned about how you were leveraging philosophy through people such as David Hume, Sun Tzu, and I guess intelligence itself is so vast and broad. We are kind of understanding the language, the natural language processing. We understand the computer vision. We are understanding the visual and audio, all that. But there are things. How do you even model like happiness? How do you model empathy? And then obviously the consciousness. Even if we create an intelligent machine, what is consciousness? What's the role that it plays? There's this, since you mentioned physics and chemistry, there's this field called panpsychism, where people say that every atom is conscious. And and the entire world is made out of nothing but atoms. Atoms, it clunks up together and it becomes whatever. I mean, trees, humans, space, star. So yes, I mean, I'm sure it's a interesting and super super deep. uh it'll take a long time to kind of, I mean, possibly understand what intelligence is and maybe model it onto a computer. You explained the time that you spent and how you leveraging different culture, religion, the works of different philosophers, and your own imagination into building this. Would you like to run us through or make us understand about the framework? What is it that your theory is all about, and what is it that you are presenting with your digital brain with artificial nervous system theory?
Our framework is actually the basis of systems theory, right? So the systems theory is not as explicit as we are, but it says that there is a space, and then three-dimensional space, and then there is a time flow, and there are objects inside which can combine and recombine to higher objects. This is the framework. And then what is intelligence after all? Well, if you take intelligence needs a body, right? It has to be a living organism, and not any living organism. For example, a one-cell organism. It has to be a multicellular organism, and it has to have at least a brain. And then you see, so it's not that not everything is intelligent. And if you see, and if this organism encounters a problem, you see it stands still. And what happens then in its brain? He is looking to the left, to the right, and what is he doing? He's analyzing things. And according to its knowledge, if it's genetic knowledge or accumulated knowledge, it doesn't matter. He then has to balance something, namely his internal needs and the external stimuli. And then what happens? He has to take a decision. Now, this decision and the result of this decision is what we call intelligence. So what is intelligence is when we are looking at something alive, a multicellular organism with a brain, which encounters a situation, and then he makes a decision, then we call it, this is an act of intelligence or not, in my opinion. So on the other hand, there are, for example, what we humans are so interested in, happiness. Well, happiness is what? Happiness is if we are in balance, right? Everything is okay. We don't have to change anything, just like in the advertising. Do you want to change something? No, everything is perfect. So we are happy. But this is just a moment in time. This means we have no problems, no situations, no nothing. Well, if this is happiness, I'm sorry, I have other terms of expressing myself, of being happy. But I guess this depends on other people. Regarding consciousness, there are a lot of theories. I also have the agree with the theory that the consciousness is a global workspace, or the theater. I call it the living room, but it's the same thing, right? And consciousness also assumes a certain organization, and the organization is the same as the cell, is the same as, so the consciousness is the same like a cell. Why? Because you have inputs, something happens, and then you have an output. If the output is a synapses, for example, for the neuronal cell, for the neuron, or for something else, there is no fundamentally difference. It's the same thing. So in computer, we would say input, processing, output, right? So the processing itself is the consciousness in this case, because if there is no time flow, if there is no comparison, if there is no situation, you don't have to do anything. So this is different. Now, modeling this, we developed the so-called 10 features of cognition. So what does it mean? How does a brain look like? in order to anthropomorphize it like a human. So first of all, the brain, which is, or let's go one step back before cognition. There are two big currents in AI today. The so-called data AI, or ALT, for alternative intelligence, is when people are using mountains of data in order to do something. This is not what I call intelligence. You don't need 1 million pictures to recognize a dog, and a baby does not need 1 million images of his mother to recognize it. So I'm sorry. So, but why does it work anyway? So what are they doing? They're taking the data and they're arranging the data to fit a certain pattern. That's why it's working. You know, just like the same thing, you go to a tailor and you want to make a tailor-made suit. You have a lot of money, you say, do that. And then he comes, he measures you, and then he cuts the material, which is the software in this case, you know, and then he says, okay, I will do it. And why does it fit you? Because it's tailor-made. So they arrange the data to fit the pattern. But then on the other hand, you have people who say we have to have cognitive AI, cognition, like in humans, right? So, and then there is another thing. What does this neuron? So what does the brain do actually? What's the structure? Well, it depends on the evolution, and there he comes. We have two types of evolution. We have evolution of the body and implicitly of the brain. Prenatal means before birth and after birth. You see, this additional knowledge, how is it acquired? By having own experience. This means there is no external guy who is telling you inside your brain what you have to do. No, you have to talk to me. That's why we talk to babies, and the babies are talking to their mother and parents and so on. And this is how the brain is doing. So evolution. And this also implies if we design a brain, we should give him the ability to do two things. First, is a self-learn mechanism. You have, without this self-learn mechanism, you are dead and buried, or you're dead in the water, right? And on the other hand, even if I have the ability to learn something, I have to store this. And this is what we call SAM, or self-associative memory. Now, every gyrus, you know, in this case, has its own self, or region of the brain, has its own self-learning mechanism and his own self-associated memory, which is something like, let's say, an embedded database. Second, you have specialties for each region of the brain. Only there are a region of the brains which have no specialty. Why? Because this will be configured later. It depends on what you learn. For example, the hand. Do you know that the hand has its own brain region? You know why? Because we are using it so much in almost everything. And this is the reason why it occupies a large amount of our brain. And then there is something else. How about we make a difference between physical and logic and mental abilities? The physical abilities are in the cerebellum, means in the back. Did you know that the cerebellum has more than 67 billion neurons? Means 3.5 more than the forebrain, the cerebrum. And the cerebrum is only for the mental abilities. So this is also a thing which nobody thinks or cares about. So this is the reason why we said, okay, you know what? Every brain is only an internal organ, and this is the reason why you have to have a framework of body hardware consisting of sensor, actors, and internal organs. So coming back, consciousness, a living room or a theater, right? It's the same thing. Happiness, this is only for a very small moment. This is when doing nothing because you don't have to do anything and everything, all your needs are okay. But this is only for a very small time. If we think in larger periods of time, like in Jainismus, you know, when they are talking in eons, for them, 1 unit of measurement is a couple of million years. Wow. But wait a second, people don't exist only for a couple of 100. Yes, I know. So you see, what it's important for us is for something else or somebody else out there, just a matter of how long.
Thank you, thank you. You went a little broad, so what I'm going to do is try and possibly simplify it to my listeners. I mean, you said that embodied intelligence is needed for creating general purpose
Yes.
machines. So possibly maybe a robots of sort, because they need to perceive the world. It's only once you perceive the world, understand the world, you become possibly then things. Then you also mentioned that maybe intelligence is emergent in itself, and you also compared it to two groups of two approaches. One is which is data heavy, who are looking at gathering all the data, and that's what's been happening with all the transformer models, be it GPT-3, OPT 175, with or everyone is looking at that direction, where it's just you gather all the data, pass it through, and create some intelligence from there. But then you are saying that we humans do not need so much data. We learn very soon. So a cognitive agent which has intelligence, something like Oz, the only way to go build something like that is something which does not require so much of data, and you say which has a self-learning mechanism built into it. So talk to us a little bit more about that. Stay in the frameworks. What is, you mentioned a couple of things. What are the other frameworks according to you think will be needed to create a general purpose intelligent machine?
As opposed to data AI, we are doing cognitive AI. Means we take the template of the brain, we extract the functionality of the biological logic contained in the brain, and replicate it. Now there is, I know there is this kind of war going on, but there is no war actually, because as just imagine, we have now software recognition, right? For face recognition, based on this very data AI. And what happens? Now we have problems, because this data AI is only for a certain template made. It's not valid for everyone. As I mentioned before, this suit only suits you because it's tailor-made, not for somebody else. Now we have it. So the problems will occur, and the more we are using it, for example, in mass transit or somewhere else, for recognizing people, for tracing people, for whatever reasons, first, there are too many mistakes, errors which occur, and second, this is not healthy to do something like this, and this also implies that we have to use intelligence together with wisdom. So we have to think about when do we use something, because otherwise you don't like it. So combining intelligence with wisdom, meaning thinking about what you are doing and what is the outcome of you, should also be included. And this is what cognitive AI is doing. It's thinking, because we have embedded in our own behavior something very important. It's called, we mimic other people. The same with the face, or babies are doing the same thing. Do what I do, says the mother or the father, and they're doing it. But after a while, if you are grown up, you begin to think. And it's very simple. Don't do to me what you don't like. This is what we call feedback. This feedback is included in the cognitive AI, but is not included in anything else, because they say, remember rhetoric in ancient Greece, the human is the greatest thing. That's what they want to keep you in the loop. The human keep you in the loop. Well, wish you good luck.
Can you share details on who are your co-collaborators?
Now we are working with another company also here in Zurich, and they are a specialist in also VHDL, and they help us together with other companies to achieve this. Why is this so difficult? Let me give you one example. interfacing with other things is very difficult because you have to create two things. One, you have to create a hardware interface, and then second, you have to create a so-called logical interface or driver, right? And here we have problems. How do you connect a camera? It's very simple. No, it's not simple because every hardware manufacturer of cameras have their own standard. And you don't have a standard like that. And there is no standard in embedded, right? And then we need it actually for three big cases. The first case is when it's embedded. This means the brain is directly embedded into the body, or edge AI, if you want to call it. Then we have the second, which is cloud AI. But cloud AI has also two different things. The first is automation, means if you are an enterprise and you want to connect different devices with each other, and here you have OPC UA TSN, long, which is actually just now defined, and there are not so many people which adopt it. It's mainly in Europe and especially in Germany. So this is the automation part, and the other part is so-called telepresence, where the sensors and the actors are at the same IP, right? And you have to connect it. And then this is another thing, because, for example, if you take a camera and voice, means sound, people usually take MPEG standard, right? But MPEG is, why do they do this? Because they encode this in order to have a much smaller amount which they have to transfer that. But this also, for real-time application, is a headache. Why? Because it's very simple. Our brain reacts within 1 millisecond or 1 microsecond. It depends where it's connected to. And just imagine you have your camera and you have your microphone, and I am here, and the latency should be only 1 millisecond. This is what 5G wants to do, right? It depends on how much data you want to transfer. So this is another point. We have some difficulties with converting this into so many standards. So we are looking now to other companies which want to adopt this new standard, but it's not that easy, you know. So creating the brain, it's okay. Connecting the brain to a hardware, that's the difficult part, and not because of the hardware interface, but because of the software interface. And there is another thing, because we are in real time and the others are not, they don't think about latency and things like this, you know. And this is the reason why real time is actually not so very well defined in these terms. Only OPC UA via TSN, means time-sensitive networks, allows this, and only for 100 megabit per second, and only for special devices. And this is because the latency is different, you know. The latency is inside the brain, no problem. But if you take the sensors, you know, the time needed, and then going back, and this is all connected via internet, you cannot control the latency of the internet, right? This is the problem. And this is why we have to make some adjustments, and this will take some time. So we are also talking with other companies which provide and develop further this automation standard, OPC UA TSN, but this might take some time. So we hope to finish this connectivity between our brain and the body, but this might take some time. For the rest, for the body, for the brain itself, when the brain is ready, means the neural net itself, the processor, that's okay. And then now we are working at the grouping, that's okay. But connecting it with the other devices, this is where we need help from other companies, and any help is welcome.
Now with data AI, if you see, there is, I mean, you know, some of the other application like GPT-3, the transformer base, it's already there. Then the OPT175 by Meta is already there. And even DeepMind just released a framework called Gato, which is a multimodal, multitask, multi-embodiment, generalist policy agent, when do we get to see cognitive AI out there? I mean, because
this may take some time, because in our approach, this is a level 3 intelligence, right? Just take the GPT-3 or OpenAI, whatever. There is no brain, there is no mouth, there is no ear, there is no inside the brain. There is, there are two different brain regions. Broca. Okay, so the point is, one is for information encoding, and the other one is for information decoding, means to speak. There is no such thing in the GPT-3. There is nothing. I'm sorry. So this is a computer application. What we are doing, we are not doing computer. We are doing a thinking machine. This is different. Why? Because this is all logic, and this requires the connectivity to a certain body. So to answer the question, this might take some time. However, this is not real time. We are not talking of real time here, and we are not talking for time-sensitive things. And these things can only be made for pleasure or work, whatever. But these GPT-3 models, you cannot put them in a spaceship and go on the moon and say, now I tell you, you should do that. He can't do that. So they are in a bubble, and this bubble is the human society, which is okay. Use it. I also use it, but you are using it for a totally another purpose as we do. So this is very different.
What's the roadmap for, because you've built a theory, what's the future?
And regarding the technique, for the first two, for level 1 insects and level 2 autonomous pilots, we FPGAs, which we are using today, it's okay. But for the level 3, we have to make our own ASICs, means chips, and these chips, because they also will be used in space application, they have to be radiation hardened. This implies that we will use the FD-SOI technology, for example, from GF or Global Foundries. And there is another thing. The brain does not need RAM memory, so volatile memory. It only needs persistent memory. This means we will develop a brain which is as big as a CubeSat, which is a small satellite, right? A cube satellite. And this has dimensions 10 by 10 by 10 centimeters. So in totally, you have 1,000 cubic centimeters. Similar with the human brain, which has 1,200 till 1,300. And then our calculations are made that it will not consume more than 100 watts, which is the equivalent of the human brain. For this, we already talked with 3 different companies which are developing this persistent memory. One is MRAM from Antaios, and then the second one is from Ferroelectric company, which are doing this FERAM 1 transistors. And then the third one is from Surface Labs, which they are putting clouds of electrons from one molecule to another. They have explained this, not entirely, because this is something new, but there is okay. And the point is that you are using so ultra power low energy that this is the something we can use and do this. So this is our roadmap. And then, of course, if we achieve this, this means that we can do, in this case, we can reconfigure any brain we want, because the software is what? Is a virtual synapses. And this means that we are doing persistent memory plus processors plus FPGAs in one. We have only one type of chips, neural chips, ours.
Thank you, Walter, for taking time, being part of a show, sharing your insights, sharing your journey of building a cognitive AI, what it'll take, the roadmap, the challenges, and the approach which others are taking. Yes, I guess from me, not like a very objective overview of mine. Yes, I think there are various teams around the world, I think, in the quest of creating uh, intelligent machines. I don't know whether it would be the data AI or whether it would be a cognitive AI approach. But yes, I mean, my heart says it should be a cognitive AI approach rather than a data AI driven, because I guess if we are creating intelligent, then the only way to get to an intelligent machine would be to kind of like reverse engineer our human brain. So I hope that's the case, and I wish you and your team the very best in the quest of building cognitive AI. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye bye. Thank you.
Thank you very much.